All right, we're on to the next one. We're still about 15 minutes late, but I see Sebastian has joined us, so that's good. It'll be nice and short, and he'll probably catch us up a little bit. The next blueprint we have
is short, yeah.
Yeah. The next blueprint we have is a little discussion on the Ceph Docker integration work that's going on. I figured any kind of container discussions could be lumped in here if people had questions, comments, or anything for the good of the cause. But Sebastian, you want to share what you've been doing lately with Docker?
Yeah, sure. So quite recently, I think it was like a month and a half, I had a look on GitHub and was looking for Docker Ceph projects, and I found a good one, a really good one, by Sean McCord. And then I thought, okay, well, it would be nice to just move that back to GitHub's Ceph. The guy was really willing to push that to GitHub Ceph, so that's what we did. And so we spent a couple of times on reworking a little bit what we had. We also have the Ceph namespace on the Hub Docker environment, so that's quite good as well. So we have kind of the official Ceph Docker images. The point is to kind of have Docker certified images for Ceph, where we know who built these images, so you can kind of safely use them with everything included, like best practices or anything. So that was one thing. So currently, what's available is so we moved everything on GitHub Ceph. So we can deploy monitors, OSDs, MDS, Rados Gateway. I'm currently working on putting Civet Web support for Rados Gateway. It's about to get merged. And so both will be available. If you want, you can use Apache, or you can simply use the embedded version Civet Web on Rados Gateway. We just merged a patch to have distributed config for Ceph using etcd, where you can simply you bootstrap your first Docker monitor, and you store your Ceph config monitor key, mon map, and admin key on the etcd cluster. So when you want to bootstrap another Ceph monitor, will have a look at etcd, and if data are available, then it will simply fetch them from etcd and add itself to the cluster. So that's a really nice, flexible, and efficient way to scale. This is available for all the components, MonOSDs, MDSs, and everything. So the only kind of problem is that it's tied to etcd, and some people are also using console. So we have been thinking of using confd just to get a proper templating abstraction for the ceph.conf that can possibly be reused by console and also etcd. So this is something that we are currently considering and where we might be working on. This is good as well that we use this that we centralize this, because I got the impression that many people started their own thing on their own, and it's good that to see that now people are really willing to contribute back what they did on their own to this official Ceph Docker thing. And things are moving quite fast. We were also suffering from a bug on the Docker side, I guess, about OSDs, and now we have a really decent workaround for that, and someone came up with its own solution. So it's really good to see that there is some traction around this. Currently, we have quite a few images, but they are only based on Firefly, because when we started it was Firefly, and so the plan is to now create branches where we have Firefly, Giant, Hammer, and so forth. So people can really have, even for developers, I think this might really be handy at some point, even to test or anything. They can quickly bootstrap new images and test their code, or think Loic does something similar, but I'm not quite sure. But it would be handy to run multiple versions of Ceph on the same machine, for example.
So in the case of so this is clearly Ceph on Docker.
Yeah, inside. Yeah.
So there's another one that I think falls in the same category. It's the Docker plus CoreOS plus Ceph. That's the second link. Lorarize Docker CoreOS Ceph one. The second link on that blueprint. Is that similar, parallel, not relevant? Given, okay.
I don't see any mention on CoreOS. Maybe it's you meant Atomic? Not sure.
I'm looking at the blueprint. The
oh, I'm not looking at the blueprint.
Second link.
I'm on the pad.
Okay. Oh, I see. Sorry. Yeah, put it on the pad.
Yeah, at the top would be nice. Yeah, I can quickly have a look. Yeah, but I personally use CoreOS. I know I shouldn't say that, but use CoreOS to be using Atomic. But
I put the link down here.
Okay, from the list then.
CoreOS plus Docker plus Ceph.
Okay.
I'm just wondering if that's a sort of redundant, not redundant, whatever, parallel effort, solving the same problem that like it's cloning. Oh, it's using.
Can I know the guy? So.
I don't know.
I think it's quite similar. Or I see he's mentioning kernel modules as well, and RBD is part of CoreOS as well. So you can already map RBD devices to CoreOS.
Meaning it's in the CoreOS kernel, or that CoreOS is doing.
It's in the CoreOS kernel.
Okay.
It's in the CoreOS kernel. Yeah, that's cool. Especially given that we don't have any kind of a storage engine, a real storage engine within Docker. Anyway, we always end up in this bind mounting solution. So, well, it would be easy to hack at the moment. Simply map the device, mount it on your Varlib Docker, or expose it as a volume, whatever you want to do. But I think it's then this is linked to the GitHub issue that Loic opened. I saw we internally discussed that as well, and I'm not sure where they want to go. So it's more about the Docker governance now, how they want to implement a storage engine solution for Docker.
Yeah.
Where you want to.
Okay. So I think using Ceph as a storage provider for Docker and or Kubernetes is like the second subject. But just before we move to that, I wonder if it's worth just poking the Lorari, whoever did that other branch, just to make sure they're aware of Ceph Docker, so that hopefully the efforts are not duplicated.
Looking at the Ceph Rados gateway driver for Docker registry. So okay, I'll have a look, and I'll ping him to see if we can redistribute that.
And then Loic has, I think there are two sets of Docker scripts. So, well, no, I guess there's a Docker help that Loic did that he uses for running. I think Loic did that actually. The CentOS Fedora Ubuntu running CI bot and pull requests. That wasn't Loic. But there's some limited use of Docker just in like the make check, and I wonder if it's possible for that to leverage sort of the standard Docker Ceph stuff instead of sort of reinventing it in a.
What would you want to do? I'm not really familiar with the. It's just like a test function.
It's just make check. If you specify a Docker config option, then it'll use Docker when it's running the unit tests. But it would be cool if in doing so, it would use sort of a completely standard-ish way of deploying Ceph for the tests in containers, so that it like is as close to the real world testing, as close to what real users will see as possible. I'm not actually sure what state it's in now, but that might be worthwhile to converge on at least.
Left a note. You can just leave a note maybe in the pad. I'll have a look.
Okay.
But like, how can I efficiently bootstrap a test environment, or is it like testing Ceph against every commit on GitHub, or?
There's a machine somewhere that is doing every commit. It does a make check, every pull request actually, not every commit. And it's using Docker. And I believe if you just in your own checkout, if you do configure whatever with Docker somewhere in there, then when you run make check locally on your machine, it'll do the same thing.
Okay.
But it's designed to run on a source tree, basically. So maybe that makes it not really solving the same problem. Anyway, okay. So the other subject obviously is how to make Ceph a storage provider for Docker or Kubernetes or other container environments.
Yeah, I'm not really familiar with Kubernetes yet. I know like the basis, but haven't played with it yet. So not sure if I can really help in that. But to me, it's just a scheduler. Or maybe it does more than that, but it looks like, okay, I create pods and with domains, and you just bootstrap containers. So you spread them to get a proper decent domain, failure domains, I guess. So I believe it's more on the Docker side, where we want to leverage the Ceph driver to store volumes. I've seen some work to use it as a base layer, but I'm not sure if it's the way to go, because the images are immutable and they shouldn't be touched. So if the host goes down, well, you don't really care about the image, just bootstrap the image somewhere else. But about volumes, then it's easier, because it's not like VMs where you have features like live migrations. Well, you can do this with containers, but it's kind of tricky. But I don't think someone wants to do this. So having a driver for Docker volume would be nice.
So there are several pull requests open that honestly I don't know. It's mostly dealing with how the volume abstraction works. So my understanding in the Docker world is that there are two ways to approach the problem. One is to implement sort of a standard graph driver, which is the managing the volumes where the containers live, and those need to support things like clone and snapshot, and for clone, I guess, is copy and write cloning or whatever. And there actually somebody wrote, I think somebody in Red Hat wrote an RBD graph driver that was using RBD volumes for each of those, and they would clone it and then snapshot clone it and then mount it, and it worked. It wasn't super fast to do those clones because RBD isn't really optimized for that use case. Like the clone operation is like several round trips when it doesn't really need to be, but also because the new cloned image, when the new container starts up, like it's a totally new set of objects, totally new file system, so there's no caching involved, even though none of the data is actually changed. And sort of the goal or the hope in the Docker world, in order to make these graph drivers faster, was have them share the page cache, which is why I think they're sort of moving towards overlayFS. So assuming that happens, then the other way to do it, also I think this is in the graph driver context, and maybe this is, I can't remember. I get the Docker and Kubernetes conversations confused in my head, but the idea was that when you're pulling down this image from the repository, and you expand it, instead of for every time you create an instance, you pull it down and expand it. Instead, you would do that once and you would extract it on a shared file system. And then you would have that be like the read-only base that you're then doing the overlay on top of.
Oh, okay.
And
across all your Docker hosts?
Right. Okay. So instead of having this like 300 meg tarball that you extract each time you instantiate something, you would just create the overlay on top of the shared file system that's already there, already extracted. That gives you all the same page cache sharing, or it gives you all the, like when you start doing cloning and stuff on top of it, then you get the page cache sharing. Even when you just have lots of things that you're spinning up based on the same image, you do that. Maybe you do already with the graph driver stuff. I'm not entirely sure. But I guess the downside of that is that you're using a shared file system as as the basis for everything in the system, and so there's like a additional source of failure that you want to worry about. You might have to worry about.
I'm not sure, but I'm more in favor of keeping the local FS, even if this always requires Windows, because you always have to pull something or you have to build something in it. But yeah.
Did you see Loic's comment in IRC there?
No.
Volume storage driver running for Dockers to use the RBD image, KRB mounted. Yeah.
So.
Yeah. Okay. Yeah. So the totally different storage abstraction that's emerging in Docker is the volume thing, which is separate from the container root file system, I guess.
From the root.
So that's what Loic's pull request is looking at. What I'm not sure in that particular case, that's a volume that's
236.
If it's KRBD mounted, it's not shared. Like it's a durable volume that can be moved between instances, but it's still only one person is mounting it at a time. It's probably useful for
Federico Lucifredi.
I think it's kind of a multi-attach functionality that we're talking about. I'm not sure if there is a system for to store metadata where you have a Docker container running and Docker knows which volume. But the thing is, if you want to run it somewhere else, then
then you can detach it and put it somewhere else. Yeah. So then there's a single attached persistent volume use case, which I think is what the current set of pull requests is about. But then there's also a multi-attach persistent file mount use case, which is like, I want all my containers to be able to access this shared pool of files that's like, the web content that I'm serving or something like that.
Yeah, with read-only, for example.
Yeah.
Read-only multi-attach.
Yeah, or even read-write. It could be read-write too if you're using Cephfs instead of RBD.
Yeah.
So Waman, are you here? I see you on the list, but I'm not.
Yes, I'm here.
You can talk. Yeah.
Can you hear me?
Is this? Yes, I can hear you. So is this what you guys are looking at? Are you looking at sort of the single attach use case or the multi-attach use case?
Actually, I think both.
Okay.
Yeah. So
in the context of Docker, the Docker volume model, or in the Kubernetes world, or
I think
both?
we haven't looked at the Docker yet. We are mostly come from the Kubernetes way of managing the volumes. So the Kubernetes essentially just mounts the external file systems as its local into its local mount points, and then exports this mount points and presents these mount points to the containers. So container will use these mount points regardless what the underlying file system is. So it could be a Ceph, it could be cluster or NFS. So you can have a unified way of treating the data, and the Kubernetes will just under the hood will mount the appropriate file system. So you can have different plugins, and the container won't see any difference between different plugins. So that's essentially what we are doing right now. And we do have a few questions and probably some help needed from the Ceph team. The problem is that the container host in Red Hat, we are using the Atomic. The Atomic is a minimum OS that you cannot install you cannot do YAML install any external packages. So any kinds of file system driver has to be presented by the container itself. It cannot be supported by the Atomic host. In that sense, if you want to mount a file system, Ceph FS, the mount has to happen in the namespace of the container, not in the namespace of the host. So there was a simple patch that's proposed by the Atomic team to the util Linux package. Essentially, they change the mounts. So right before you mount the file system, you switch the namespace and get the namespace of the container, and then let the container mount the file system. And both the container and the host can see the same file system. So that's the idea.
And that would run in like the super privileged container?
Yes.
That's the idea?
Exactly.
Okay.
Yeah.
And it can switch to a sibling unprivileged container so that it gets mounted in that?
The sibling is the switch to the host, and then the host will just bind the mount again.
I see. Okay.
Mount bind, and then let the bind mounts to present it to the container. So that's the basic workflow. So far, also look at Ceph. The stage you just send the message on the CoreOS way of using Ceph. That's way actually, I also propose that way. So essentially, we copy everything from the binary into the host, and so the host does not have to do the YAML install. It just gets the binary directly. But that idea is not well received here. So so far, the namespace change and the super privileged container are the only solution right now, which means we have to change every month utilities, Ceph, Cluster, or NFS, whatever.
Yeah. I mean, I think that sounds like that'll work. I mean, at a high level, like, I don't see any reason why it doesn't work. Practically speaking, it sounds very inconvenient. Like, honestly, it seems like it would be so much simpler if we just installed mount.ceph in the Atomic host context, and then all those problems go. I mean, they have mount.nfs. I don't know what, but that would obviously be the simplest thing. It might be possible to avoid patching mount that way if you do an LD preload and capture the like the mount syscall basically. And so then you could run an unmodified mount inside the super privileged thing, and it would do the set NS in an LD preload library. That would avoid you all the pain of patching all these things. That might be worth checking.
And I think that is a great way. So can you just, if that does cost you a lot of time, would you mind just writing me, the instructions how you're going to do that? It essentially intercepts the library, and then you enter your own hook into that library.
Yeah, it's been a while since I've done it, so I can't remember the details. But basically, you define a function in a .so that has the same signature as mount.
Okay, so
and
essentially
then you do LD preload.
Oh, I see.
With that
I've done that
library.
before. Okay.
Yeah.
I think that's great. Yeah, we can do that. Okay, that seems like a perfect solution. No, there's one. Let me check this first. This could work.
Okay.
It probably only has to happen before you run because it has to also be patched into the utility function, the helper, the Ceph FS helper function. So that's where you don't have a library.
But it's
called library. The mount itself is a top level mount, and then you call the Ceph mount.ceph. Okay.
But it's only right before you call the mount syscall that you need to switch the namespace, right? That's the only change. Or is there other stuff that's actually happening?
Okay, let me see. This is probably just only you're probably right. Yeah, that's probably the only page you need to change. If that's the case, then that should be easier to implement. Okay, I think that's a great idea.
Okay. You might have to do something tricky like bind etc mtab and so forth into that super privileged container so that mount doesn't get confused about what context it's running in. But it
Okay.
It's probably better than the packaging.
You have to provide an option to enable that That's a intrusion. Yeah. So
but this is an atomic specific problem though. Like Kubernetes in general won't have this issue because all.
Issue. And if you are running CoreOS, CoreOS may have the same issue because CoreOS by release not package any non-helpers from Ceph or any file system. So it's just a minimum OS. So it could be Kubernetes on Atomic and CoreOS.
Do you guys do you talk to the CoreOS people? Like, do we know if they would? It would be nice if the problem were solved in the same way on Atomic and CoreOS.
I think probably. Yeah, I don't have a connection with CoreOS guys. The relationship between us is interesting.
Yeah, of course. we can ignore the politics, hopefully.
Definitely.
Okay.
We can also work that way.
Right. Okay. So, but at a high level though, and ignoring the sort of the mount gymnastics, the host will mount the Cephfs volume, and then it'll bind mount it into the container. And that would be you do the same thing both in the context of if it were the Docker driver that's using whatever the generic Docker abstractions are, that would do that, or in the Kubernetes world, we'd write a Kubernetes driver that would do the same.
The Kubernetes will do the same. So you don't have to deal with any specialties in the Docker. So you can just use vanilla Docker without any specific volume plugins. You can run it because it's just a generic host mount. So
yeah. Awesome. Okay. And I think I mentioned this on a different conversation the other day, but I had a conversation with Tim Hawken, one of the Kubernetes guys, and he was basically saying that to get a basic Kubernetes driver that would just do this Ceph mount and then bind it into the container is pretty simple. But it sounds like that's what you guys are already working on. So
yeah, that's the one. We already have the pieces connected, so we can add another drivers relatively easily because we already have the top level built up. And the down level, we just need to have the attach and detach things work. So you can attach to any kind of file system, and that's is very file system specific. You just run specific commands and make that happen. So I think that is a relatively easier part to do.
Okay. In the case of Atomic, is it like a RHEL 7.1 kernel? Is that what it's based on, or is it something different?
Yeah, I think it's a RHEL 7.0 at this moment. I mean, as last time I remember, it's probably moving to a RHEL 7.1.
Okay.
So it's a moving target anyway.
Yeah. So in the 7.0 kernel, it's a pretty old version of Cephfs. You'll want to use the 7.1 kernel at least, which has backports as of like 3 months ago. So it's reasonably up to date.
Okay, 7.1. All right, I'll check that.
Yep.
We getting
close on Fedora 21. Do you still have any updates on the Fedora 21? Because Fedora 21 still use the Firefly, and there's some differences.
Yes. So, really soon now, like 2 weeks, as soon as Hammer's released, then that's going to be fed into Fedora. So I don't know what the Fedora release schedule is. I don't know if it'll go into the current Fedora or it'll be the next Fedora 22 or whatever. 21, I lost track.
Do you still package the package for Fedora? Package the latest release for Fedora, or just I noticed there was two repos, one from Ceph and one from Fedora. So which one?
So in upstream Fedora, we always give them the latest stable package. So that's Firefly right now, but it's going to switch to Hammer soon. If you go to ceph.com, you can get any version for Fedora pretty much. And I'm 95% sure that we're building those packages currently.
It's just not built for Fedora 21. You can get it from Fedora 20, not Fedora 21. So somehow, if you can just let somebody build one from Fedora 21, that should be great.
Okay, I'll add that to the list. Fedora 21. We need to add that to the release matrix. Is Fedora 21 out?
Yeah, it's already out.
It's out. Okay.
Yeah, that's essentially the way we play with Docker Kubernetes.
Got it. Okay, perfect. Okay. Cool. I'll put that on my list.
Thank you.
All right, we're still running about 15 minutes behind, so we set with this one?
Sorry.
That's my
I think
fault.
so.
All right, cool.